All right, everybody, welcome to Tesla Today. This is a very important show. I'm very, very excited about this one because there's going to be one breaking news, and we're going to have two very important news about Tesla Bot and about FSD. They are coming sooner than we realize. Today, I've got Hans Nelson with us. He has his own YouTube channel as well, and he and I have been following very closely two videos that came out by Ashok, who's the director of Autopilot for Tesla, and they're very important news. And there's another big one that's coming today about the bot too. So welcome, Hans. Appreciate you joining me.
Thanks for having me, Herbert. Looking forward to this conversation.
Yeah, so there's a lot to cover here. You and I have been watching Dr. Know-it-all's videos. If folks here haven't watched that, you should get there. Let's get right to the breaking news. So basically, this came out yesterday, which is a note at Tesla Motors Club saying that Tesla currently has 52 job openings for the Tesla bot. Wow. So already they're hiring people, and 5 of these are specifically for manufacturing. What's even more exciting, this person says, is that one of these positions is for line lead role in Sparks, Nevada. So if you look closely here, there's actually both Palo Alto and Sparks, Nevada. So I think that this is coming way sooner than we realized. This is the line lead in Sparks, and then you've got your Palo Alto, which we knew that they've already been designing for it. And this is the actual job description for the line lead. You can see it says here, determine layout of production line workstations, determine procuring equipment, and so forth. So Hans, when you saw this, what did you think? I mean, there are people who are telling me that they think that this is, well, this is part and parcel of what they do. It's going to be 2 years from now. They're just setting up the line now, preparing ahead of time. What was your thinking about this?
Well, first of all, I think we have to think about the bot differently than we think about cars. So it takes a lot longer to set up a manufacturing line for a much more, and it's not just a manufacturing line, but a manufacturing line and a supply chain for a much larger, heavier, more, a product with many more parts than it will take to set up the bot. So, just right off the bat, I don't think that you can make a direct analogy from, say, the CyberTruck all the way and how long it's taken to get that set up to the bot. I have spoken to, so there was the manufacturing line lead for the Cybertruck. I actually got to have a brief conversation with him at the Cyber Rodeo, or not the Cyber Rodeo, but the Tesla Bull Stampede in February this year, and they had been working on getting that line up for a while there, and that was basically his job. We're trying to put all the equipment in place. We're trying to figure out what the manufacturing processes are. So if they are just now getting ready to hire the person whose job it is to figure all that out, that means they're still a little ways out from actually getting a pilot line set up in Sparks, Nevada. But it does bode very well for the progress of, obviously they're adding a lot of headcount there in Palo Alto, which is where they're doing all of the prototyping and the development work for Optimus. So the fact that they're already ready to start planning for production in Sparks, Nevada means that the prototype is actually going really well right now, and they have the physical componentry getting close to what they feel like is production ready, that they can begin to order, figure out what all parts are going to be produced in-house, what parts are going to be produced by third-party suppliers, and begin establishing those relationships with who those suppliers are going to be and getting manufacturing ramped up for the suppliers as well. So my guess is that we probably see the first prototype of a bot roll off of that assembly, the line in Sparks, Nevada, somewhere in the time frame of 1 to 2 years from now, because they're going to bring this person in. It's going to take them a while to plan everything, and then they're going to have to do quite a bit of installing and getting everything kind of sorted there in Sparks, Nevada, before they can even get the first alpha builds off of that prototyping line.
Okay. So I do agree with what you just said, right? Which is, one is the Tesla bot, it does not take as much time to build than a car, right? Let's just be very clear about that. We've had experts like James Dalma and Scott Walter Scott Walter owned two robotics companies in the past, and says they've looked at every single part that's associated with this. They can produce this now. The thing about the production line is when they need to produce this at mass scale that they're going to likely sell. I think that that does not mean that there's going to be a delay in actually creating these bots just by hand, making 1,000 of them, and actually using them internally for their own company. Tesla using it for their own company. And just the fact that when they show that this is actually being used practically at for the factories, that's enough to get everybody excited, to people realize that it's inevitable. So I just wanted to, that's my opinion, that I think that
Mhm.
while what you
Yeah,
said actually is, yeah,
I
just
I
let me
think I
finish that
agree with
thought,
you.
which is, yeah, just let me finish that thought, which is what you said was that the fact that they're building this line now means that they are confident they're getting close to actually finalizing the design, which is sooner than we were thinking. Okay, because they really only launched this a couple of years ago. They had a really weak prototype 6 months ago. So for them to feel confident that they might already be like honing down on the actual design and for them to start planning the scale, I think that that's what I'm seeing here.
Yeah, I would agree with that, and I think that they're going to be, continue to build out quite a bit of, or quite a large number there in Palo Alto, or from now until the time that and even they will probably continue to build Optimus bots in Palo Alto even after the line in Sparks, Nevada starts up. And so they're going to continuously produce Optimus bot in Palo Alto between now and then. Just like you said, they'll use those bots internally in a variety of use cases to continue to validate the physical design, the hardware, and then to build out the software, because the hardware constraints can morph over time as the software improves and gains functionality. There are things that they might have to do to compensate for poor levels of software to begin with, that as the software becomes more built out, that they actually don't need. So the further they can get along in that software development roadmap, the closer the hardware design will be to a much more finalized design. But yeah, I especially with the, how small these bots are, and like the ease of manufacturing them once they get to scale, I expect the design to just evolve extremely rapidly. And we've seen the evidence of that from the outside, that, basically no two of the prototypes that we have seen thus far have been identical. They all have little individual changes to them, just like SpaceX, the early Falcon 9 rockets, they would call them, there's block this, block, block 1, block 2, block 3, block 4, block 5. But even within a block, every single individual booster would have its own unique characteristics to it. And so they are able to handle that. First of all, it's just anytime they see, hey, this is an improvement that can be made, they make it in the process of producing that unit. And that unit has its own digital twin. And so that they can do a lot of validation testing in simulation on that specific model, even though it has different build quality, or, different components, different designs of pieces that are used in it. And we're just going to continue to see that from now until the time when these things, and it'll be really behind the curtain for most of, like, other than the demo videos that we see, there's going to be so much going on under the hood that's completely opaque to us outside of the company, because they are going to be using these all over in a variety of, I'll bet you there's going to be some that are sent to warehousing. There are going to be some that are sent to the auto manufacturing floor. There are going to be some that are sent to work in Buffalo, New York on the, gosh, why am I blanking out on, is that where they build superchargers, I
Superchargers?
think?
Yeah,
Yep.
Buffalo, New York, superchargers. Yeah.
Mhm. And then to Panasonic or in Texas to work on batteries. Like, they're going to use them a little bit everywhere, and they're just going to give them to teams of people and say, hey, like, abuse the heck out of this, and like,
Hmm.
tell me what's wrong with it. And so all of that is going to be going on. And then we'll see little snippets of that they decide to share with us at, AI Day 3 or various other, basically every single presentation. Like, this is one of the core focuses of the company now. And we see that because it doesn't matter what the topic of the Tesla event is. They always give us a little update on what's the progress that Optimus is seeing right now.
I can't believe this is happening in my lifetime right now. We're talking about a factory producing robots in mass scale, and we just saw the hiring of the people, and they're probably going to start building, the lines now. But so I again just want to repeat, I don't think that this means that there's this delay or we need to wait for 2 years. Actually, not. And actually means it's accelerating. And I am very convinced that in September or October, whenever they hold AI Day 3, it's going to be a big, giant come out to the world, show folks that these bots are real and they're already working. And they're going to be in mass numbers. If you watch how they first showed just one or two, then they showed six. Now they're going to show 30. They're going to show maybe even 100. They want to impress the world that Tesla is an AI company. They need to get the top engineering talent to come to them to be excited. And I think this is one way that Tesla can convince the world they're an AI company. Because sure, there's robotaxi, but people still don't think of that as AI for some reason. Like they want to play with it. But when you see a bot and you could talk to it and then you could teach it something, that is going to be crazy. So we're going to show videos from Ashok talking about FSD, but he does say very clearly that it also applies to the bots. Yeah.
I just want to make one clarification on the 1 to 2 years. That is
Yeah.
going to be a knee in the curve of their production rate. So they're going to be building them at a slow rate in Palo Alto. And
Yeah.
then they will be able to go from making, it'll be maybe 5 a day or 10 a day or some number a day that is probably 10 times less the production rate that they will have once they get everything built out in Sparks, Nevada. And then it'll go from having a slowly growing fleet of Optimus development bots to just cranking them out. And you can think about it similarly to what they're going to end up doing with Starship. Like, they're producing one Starship every few months at this point.
Mhm.
And then, but once they get that design finalized, they will create a whole new production line around Starship, and then they'll start cranking out Starships in the single digit days. And so it'll be similar with the Optimus bot that, there will be one production rate, then they'll get that new manufacturing line and it'll just go vertical.
Yeah. Okay. This is massive. It's probably the biggest thing that's happening to Tesla. It's crazy that we're even talking about this. Bots is real and they're here. Don't have to wait long. Meanwhile, some people think that FSD and robotaxi is going to come sooner than bots. I've been saying actually I think bots will be here sooner, but they're both coming at exact same time, so it's quite exciting. Let's share that right now. Just yesterday, Elon was the first invited foreign speaker at the World AI Conference in Shanghai. So he was there and he started to speak about it. So first of all, for him to have been invited, it's a big deal. So this is what he says. Let's watch the video that he talked about. It's when you listen to this video about FSD, it's going to be something you have heard him say a few times, which is FSD is real and it's coming. But just watch his confidence in here.
Um, I think we are very close to achieving full self-driving without human supervision. So when I drive a Tesla car using the latest full self-driving beta, I almost never need to touch the controls going from one destination to another. Again, this is so much speculation, but I think we will achieve full self-driving, depending on what level you call it, 4 or 5, I think later this year. So now I've been wrong about this prediction in the past, but I feel like we're closer to it than we ever have.
Hey there, thank you for joining me. If you can, please consider supporting this channel so I can keep it going. It's a lot of work arranging all these amazing interviews. One of the easiest ways is just to click that join button and become a member of the channel. Thank you very much. Let's get brighter. Okay, well, so we've heard him say this many, many times. Okay, he's been saying this since 2015. Some people say, although he was actually referring to autopilot from 2015 to 2018. Certainly, he has been saying FSD is coming this year, and each year he was wrong. However, he's been saying this many times this year, and there's two reasons why I actually believe him this time. And the reason I believe him is because they talked about Dojo, and we'll talk about that, which is a supercomputer. And then two videos from two of the actual engineers working at the FSD, and we'll show some of that. What was your what's your reaction when you saw that?
I think it might be better to save it for after. basically the short answer for right now is that I think it's going to take longer than the end of this year. I'm hoping that we see something really impressive by the end of 2024, and that it will basically become clear at that point that this is going to happen, and it's just a matter of time, that all of the capabilities of the system are there and they're ready, and that there's just some polishing work that needs to be done. But I honestly, I don't expect us to see that product released by the end of this year.
Yeah, it's a tough bar, right? Because he's talking about level 4, level 5, which he just said,
Mhm.
level 4, level 5. That's
Yep.
robo-taxi. That is not touching the wheel. Everybody will
Yep.
say there's like the March of nines, 99.999999, and you can't be
Mhm.
that issue. There are, of course, robo-taxi today being used in select geo-fenced locations. Cruise and Waymo are doing it. They're getting paid to do it. So kind of this weird dichotomy of some people saying it'll never happen. Don't you know the 99? You have to be 6 nines of safety before this will ever be rolled up, and yet it's already happening.
Mhm.
There are
So
already jurisdiction. Yeah,
yes, the difference in what Elon is saying now versus in the past is I really do believe that he's correct in that they have the right architecture under the hood, and that's what we're about to dig into to actually be able to achieve a good
yeah,
generalized solution to autonomous driving that can go pretty much anywhere, unlike the geofenced solutions that Waymo and Cruise and these types have. So, that's one thing, and we'll examine that here momentarily. The What it basically boils down to is that we have seen the proof of concept now with GPT-3, GPT 3.5, GPT-4, and then the Chat GPT product that's built on top of GPT-3. You can switch out under the hood which GPT model that it's running on. Um, but the way that those are trained is essentially the way that they are moving to training full self-driving. And so we have seen that this has worked in the space of language. And now the problem is that, just think about how large a text file is. It's tiny. And they had to feed all of the text on the internet into GPT-4 essentially to train it to get this incredible foundation model that is capable of interacting with people through Chat GPT in a very human-like manner. To store, an hour's worth of reading in text
Mhm.
is on the order of kilobytes. To store an hour's worth of viewing of a very small frame on your computer, well, now you're talking about megabytes, potentially even gigabytes, depending on the file type. And so the density that you have to process if you are trying to train a video model that is the equivalent of GPT-3, you're going to need tons more. You're processing a lot more data, orders of magnitude more data, which means you need orders of magnitude more compute. And so that's what they're building. And they are training it in, the way that these LLMs train is an autoregressive, general purpose transformer that they basically put a giant blob of text out, and then they block out individual words. And they say, can you guess the words that are there? And so you don't need labels. You don't need special training data. It's self-supervised. You don't have to have humans in the loop of the training. It can just feed in data. It can do some masking, and then it can try and make predictions, and it can tell, did I get the predictions right or did I not get the predictions right? And Tesla is essentially doing this with video now, that they're feeding in video frames, and they're saying, okay, like, we're going to take video frames away, and we're going to ask you predict what the next video frames are going to look like. And the model can actually do that. And interestingly, it can even do that in a way that you can prompt it exactly what type of video frames do you want it to, if you're driving along, do you want it to predict, I'm going to continue in this lane, and this is what the video frames that I would see over the next 10 seconds as I continue in this lane. Or you can say, hey, I'm going to make a lane change over to the right, and it will predict all the video frames that the cameras would see if the car made that video, or I mean that lane change. And so they can train in a self-supervised way that removes the need for a lot of labeling. It allows them to get a very general model, just like ChatGPT or GPT-3 has a very general model of language. It can interact in any number of ways, like a doctor, like a lawyer, like a first grader, like a second grader, and they're building that type of generality into the video foundation model that they're building and putting things on top of. So yeah, that's what.
Okay.
That's
Yeah.
kind of a primer. Yeah, let's watch some of that in the video.
Let's watch it directly from the directors of AI, but you've done a good summary of what we're saying. Basically, what I heard you say, of course, it's much harder to do video. Absolutely. So you need to have supercomputer. Let's talk to Dojo. Secondly, they're using the same kind of philosophy and platform that ChatGPT did to predict the next word, the next sentence, and you can see how successful it's been. They're now using that same model to predict what's going to happen to the scenery and to generate the a model, right? A sort of a 3D construction of the world. This is so amazing what they're doing. So let's dive right into that.
And just to say that this is why they have confidence that it's going to work this time, because they've already seen that this has worked in other realms, and there's nothing special necessarily about, the general purpose transformers can process video or audio or text, or they're using it for like the language of lanes. Like the nature, the modality of the data itself is not really going to make a difference, and so that's why they think it will work. And so when Elon says, I think that we'll have this by the end of the year, that is his internal target for, it'll be V12. I want V12 to be rolled out by the end of the year. And so the question is, well, how straightforward is it to roll out V12? Is it going to take longer than the end of the year to get it? And then once it's rolled out, how much actual supercompute capacity do we need to have installed in order to really make that V12 model the fully built out?
Sure. But what I'll say is that when you see these videos, which I want to get to very soon, is like they are saying that they've already been doing it. They've already been doing this, and they know that it works. This is the confidence. You got to listen to their voice. You got to watch what they're saying. This is no longer this. We think we need to put this together. So we know this, right? So we know that they've showed this, which is Dojo is going to be in production this month in July. Elon even tweeted out saying that it was actually, already in production in a month already. So they know that this thing's working, but look how fast they're going to blow this up, and they're going to be 100 exaflops. And so even by next year, we're going to be already the largest supercomputer in the world. And this is designed specifically for video processing. So just to clarify, Elon said this before, Dojo is highly optimized for vast amounts of video training. That was what it was designed for. The NVIDIA cluster, which they're using, is designed for other things like gaming and others, not for machine learning. And that's what Dojo was designed for. So this is going to be much more powerful. But they also are.
He is comparing those to the NVIDIA A100s, and they're specifically designed for machine learning training, but not necessarily. So they're more designed for processing text data, just like all the data that GPT-3 was trained on, versus, video has some different things about it so they optimized Dojo specifically for video data as opposed to any different type of mode of data. And obviously, Dojo V2, they're going to expand that back to be more general.
General.
Yeah, audio,
this
text.
is going to be bigger.
Yeah.
It's going to be huge. But right now, that's what it's for video. Then he says, this second sentence here, we just need a crazy amount of training compute to get full self-driving 10 times safer than a human, but can't get enough GPUs, plus prices are extremely high. So at least they have their Dojo to make sure that they get what they need. And you can see they're expecting exaflops, much more than anybody in the world has. Okay, so let's watch some of the videos here. This is Ashok, director of AI, talking about what they've just built, which is this ability for creating a general model. I'll play a bit of it, and then we can stop and talk about
this like base structure of trajectories, calibration, from all these cameras, you can really do a lot of cool things to reconstruct the entire scene. I'm not sure if the video plays quite nicely, but in my own screen, it looks very smooth, where you can see the ground surface. It's reconstructed quite nicely. There's like no artifacts such as double vision or blurring. Things are like crisp, look like geometric, they are correct. This is a hybrid approach to NERF and general 3D reconstruction. Sometimes in NERF, even though the re-rendered visuals might look very nice, the underlying geometry might be very fuzzy. And
all right, let me, I'm not an expert in this space. I highly recommend people watching Dr. John Gibbs, Dr. Know-It-All's channel to understand better. But what we just saw there is when he's saying NERFs, that's neural radiance field. So that's taking the 8 video cameras and actually seeing video output, stitching them together, and then be able to show you what the world looks like after a car or multiple cars have driven through it. What we just saw there is a 3D construction. After many Teslas have driven through one spot, it can now reconstruct it through just through simulation and just create it. But you can see how precise it is. It sees trees, it sees cars, it knows the length of the height of the curbs. It even had words on the signs. And this is them being able to recreate it. And what that does is that now you can basically have a map of the whole world. And then you can predict what's going to happen in the future, just like you were saying earlier. So, yeah, what did you interpret that to be?
Yeah, that's pretty much when he says hybrid. I'm not exactly sure how to interpret that. If he's saying that there are other sources of data that they're stitching together with a NERF, or if that's just when he's saying hybrid NERF, that it is the compilation of a variety of different NERFs that were generated by each individual trip of a vehicle through that space. I'm leaning towards the second is what it sounded like to me. But yeah, we know that they're using, they reconstructed that scene from a number of different video clips of cars passing through that area. And so I think that's exactly what he's saying, is that, that's just multiple NERFs kind of all compiled together, and then ground truth and reconciled with one another. And the interesting thing about that is that what they're getting out is something that is as accurate, if not more accurate, spatially than you would get from driving a LiDAR vehicle. One of the things about these companies that are using LiDAR, well, there's a limited number of vehicles, and they have a limited number of places that they can go. Like the amount of data that you can collect back is going to be limited by the number of vehicles that you have on the road. So Tesla's able to capture data that, maybe it's only 20 or 30% as good as a single pass through that space with a LiDAR from a spatial geometry standpoint. But you can put, thousands or hundreds of thousands times more cameras on the road. And so you can quickly get much better mapping because you have a much higher density of sensors that are traveling. But on top of that, you're not only getting the geometry, you're also getting all the visual information, which is also very important. And so this is another thing that Ashok talks about later. Like, they're getting all the signs, they're getting all the road markings from this. And so like LiDAR is never going to tell you where are the lane lines, where is the stop mark on the ground. So you have to have the visual data anyways. And so if you can just put a few extra, if you can put more cars on the road that have cameras, you get all your LiDAR data plus all your visual driving cue data that you need as well. And this is why Elon has said for years and years and years that LiDAR is a crutch. And honestly, it's not actually going to, like, you're still going to need cameras. And so just go all in on cameras and make your cameras so good that you can actually accomplish the same task. And so we're seeing that here. They'll be able to make the highest resolution, closest to real time model of all of the drivable space in the world, better than Google. Right now Google is paying people to go drive around everywhere with their 3D cameras just to give you a street view, and that street view is not a high-res map. And so they'll be able to provide more and better data than Google Street View that actually provides those high definition maps that, hey, if you want to develop an autonomous vehicle platform that uses high definition maps, okay, like you can just port into Tesla's world model and you can download the data directly from them that is created and maintained by the Tesla fleet. If
Yeah.
you were so inclined to do that, no one's going to do that, but like they can essentially intermediate any need for any LiDAR mapping service that any startup would want to create.
Yeah, very good. Thank you for comparing that. So you don't need LiDAR. LiDAR is going to be able to get a very high definition map of things. But now every car, every Tesla driving through any street is mapping this, able to recreate it. Multiple Teslas will even make it stronger from all angles. And now Tesla says that in San Francisco, for example, you can actually create a game, a video game, and then you won't even distinguish it from reality, because it's going to be like, it's like as if it's like it's not just a video that they're showing you, but they can reconstruct it so it looks real. Everything everything being trapped. You saw that: cars, signs, lights, birds. Anyway, so this is why also that they've confirmed, right, which is in certain cities it is overfit for that city. So that's why people who drive FSD in San Francisco get much better kind of less disengagement than somebody doing it in a rural town or Chicago. And people say it doesn't work, well, that's because there's not enough Teslas there yet, or they've not yet chosen that city as something that they want to feed all the data in to work it out. But this is proof that they can do this now, and that's why the excitement is happening.
I think that part of that is, it does show that there are little kind of crutches and shortcuts that they have made in order to make it work so good in that city. And especially, they really want it to work well. Honestly, so I think this is another factor in why Elon is always wrong about his prediction on when this is going to work. Because Elon is forecasting, how well does this work for me? And he thinks that all the FSD cars, it works out well. Well, there's a dedicated team of people that, like, their whole job is to give little shortcuts to Elon's car so that it behaves better than any other car for his drives. And so, his sample is very distorted. It's not a representative sample of what it can do. But as they get this general world model working better and better, they won't have to focus on how, does it work in this Chicago versus LA versus San Francisco versus Cleveland, versus some little tiny town out in the middle of the sticks. Those things, once they get the solution all the way there, all those things will work at the same level, all at the same time.
Yeah. Okay. Let's keep watching. There's
in this case, what we do
lot
is
of clips
we have
here
a
for
neural
us to see.
network that can be conditioned on the past or other things to predict the future. And obviously, everyone has wanted to work on this forever. And I think with the recent rise in generative models like transformers, diffusion.
I want to pause it very quickly there, just so you know. You guys are taking a look at all these videos. Okay, there's 8 cameras. When I see that, I think, oh, okay, that's just my car driving down the street, and you're just showing me the videos. That's not what this is. Those things we're watching is the computer creating those. That's not a video. That's the computer. That's Tesla's system predicting what they're going to see. And what you hear him say is that it's like the rear camera is very much in sync with the front camera. As they predict what they're going to see, you'll see that the rear camera is actually tracking exactly what they saw in the beginning. This is a computer recreating this scene,
etc. We finally have a shot at it. So what you're seeing here is purely generated video sequences. Given the past videos, the network predicts some sample from the future, hopefully the most likely sample. And you can see that it is being predicted not just for one camera, but it predicts all the 8 cameras around the car jointly. And you can see how the car colors are consistent across the cameras. The motion of objects is consistent in 3D, even though we have not explicitly asked it to do anything in 3D or not even baked in any 3D priors. This is just the network understanding depth and motion on its own without us informing it of so. And since this is all just predicting future, RGB values, the ontology is quite general. You can throw any video clip from driving, or from YouTube or from your own phone. Anything can be used to train this general dynamics model of the world.
All right, so a couple points. There's so many good things here. So what you're seeing there is the computer generating that. And you look at it, it looks like a real video. You can't even distinguish that from reality, what you're seeing there. And then he says at the end there that you can now take any video, not only from your cars, but you can take videos from YouTube and feed it to teach it how to then predict the future. And this is what you were saying earlier, that it's the same way that ChatGPT basically takes all the text in the internet and then it predicts what the next word would be. Therefore, and then it comes up with an amazing sentence. And we all just shocked at how perfect an answer it is. In the same way, this is using the same model where it can now regenerate a driving sequence and then predict what's happening. And you can see how accurate that could become. So, yeah.
Exactly. And so you can kind of get a sense for this intuitively, that if you, like, in order to understand how to break all those, those are two-dimensional slices of the world that the car or the neural net is having to figure out what's the relationship between each of those two-dimensional slices and some three-dimensional, like, real world physical thing. And by doing that, like, they can see, hey, there's some relationship between all these cameras. Like, I always see objects kind of moving from here to there, and just with enough data, they're able to get this very accurate three-dimensional understanding of the world, just like humans do with, we have our two eyes and we understand the three-dimensional, like, it just, no one has to teach us that the world is three-dimensional explicitly.
Yeah.
Like, we develop that understanding just by observing two separate two-dimensional views of the world constantly. And so we have this feed of data, and it wires the neurons in our brain to make that extrapolation out into 3 dimensions. And so they've figured out how to do that exact task like we do as babies learning to see. They've figured out how to teach this general physics,
they didn't teach
3D
it.
vision model. Well,
I
yeah,
remember them specifically saying that the neural net figured out the depth in the 3D version of it.
They figured out how to feed it the data, and then for it to have that aha moment, basically, and figure out all those connections and relationships on its own.
Yeah, they didn't code it. They didn't say that this is not 2D, this is 3D. It figured it out on its own. So that's examples of what we're talking about. This is neural net. This thing is teaching itself. Okay, let's watch another continued clip of this.
Additionally, it can also be action conditioned. We can show a few examples. So here on the left side, the car is driving in the lane, and we're asking it to, okay, just keep in this lane and keep driving. And then, like I said earlier, the car is able to, or the model is able to predict all of this geometry flow by very nicely and understands 3D. On the right here, we're asking it to change lanes to the right side. Maybe we'll go back and play it again. So on the left, it's just going straight. And we ask it to go straight, the model goes straight. And then on the right side, we ask it to make a lane change, and it makes a lane change. And the past context is the same for both of these outputs. So given the same past, and when we ask it for different futures, the model is able to produce or like imagine different futures. This is super powerful because now you have essentially a neural network simulator that can simulate different futures based on different actions. And unlike a traditional game simulator, this is way more powerful because it can represent things that are very hard to describe in an explicit system. I'll show a few more examples, but then it is super powerful. And also the intention and then the natural behavior of other objects, such as vehicles, is very hard to represent explicitly, but in this world, it's very easy to represent.
Okay, yeah. So this is simulation, which they had before. But simulation before was they would take video clips and then they would try to see what the computer would have done, what FSD would have done in that scenario. But in this case, because they can do 3D reconstruction of the simulated world, everything you saw was simulated.
Mhm.
It was created by the computer. Now you can make all sorts of things and see, like you said, that you can tell it what to do and see if it does it right. And so that's going to just super accelerate their ability to teach this, or for it to teach itself.
Well, that model that he showed, there was nothing explicitly 3D. So, if you try to create a simulation, usually you're using some sort of software package like the Unreal Engine, something like that.
Right.
There's a lot of specific formulas that describe how does physics work, how does three-dimensional space work, how does light interact in a three-dimensional space, and it's using all of this complicated, discrete math to try and show you what it would look like to do a certain thing. That's not exactly what's going on here. This is just a neural net that doesn't have any of those hard-coded formulas anywhere in any of its code. All it is saying, here is some video data of where you just were. Now show me what the next however many frames they want to do. I think they're operating at 36 frames per second. If they want 5 seconds of video or 10 seconds of video, that's 360 frames. Show me what are the next 360 frames going to look like. And it will do that, and it'll just directly project that into those camera views. Now, if you wanted to go and turn those camera views into your ground truth three-dimensional space, you could do that. That would be a separate, that would be going back to what we talked about earlier when they used the nerfs to reconstruct the 3D space, and that would be a whole separate operation. This is just, I'm feeding you the 8 camera datas, the 8 cameras worth of data for where you've been, and now I just want you to project that into the future, just like we talked about with the Chat GPT or the GPT training, where they would mask individual words and ask them to predict that. And so, yeah, this is why it's so interesting and powerful, because there is no explicit understanding of how the world works, how physics works, how light works, how any of these things interact together that is given to the model. It just learns the patterns that it sees in the video data and is able to project that into the future. And that's much more reflective of how we as humans learn and understand how the world around us works.
We think we are on the way to become one of the top compute platforms in the entire world. And we also think that to train these foundational models for vision, we need a lot of compute, and not just compute for training this one model, but compute to try a lot of different experiments to see which models actually work well. And that's why it's super exciting for us to, be in this spot where compute is going to be abundant, and it's just going to be bounded by ideas of engineers.
Okay, and then let's continue with this one, which is, this is not just for cars. This is also for humanoid robots.
The thought is this is not just being built for the car, but also for the robot. We already have the occupancy networks, for example, and a few other networks all shared between the car and the robot. And it actually works quite well and generalizes across these platforms. And we want to extend it to all the tasks that we have. Even like lanes and vehicles, for example, should not be specific to cars. If the robot, say, happens to walk to the road and looks around, it should understand roads and vehicles and how vehicles move, etc. All of this are just be built for both the platforms, and any other future robotics platform that would also need this.
Okay. Whoa. So everything we just did, and then he was asked through Q&A, when might this be available? And he had a very long, awkward pause, very long pause. Then he answered, and he was trying to think about what he could say and not say, but he just said that this is going to be in customers' hands by the end of this year. So you have these engineers who are not prone for,
He said maybe by the end of the year.
Maybe. Well, but my point is that, come on, it doesn't matter. Right? He just said, most people would have said, don't know when, who knows, whatever, but not like an Elon will say it's going to happen by the end of this year, right?
Yeah. Well, my guess is Elon's alpha build is already driving on this stack. And so they're hoping to roll this out to customer vehicles by the end of the year. And that's where I say I'm still dubious on whether or not that will happen. But yes, it's incredible. And Phil's talk really kind of explains more what he's talking about. But what they realized that they were doing, and it was kind of clear that this was the path that they were going to have to take, is they kept building individual, you could think of them as basically Lego blocks of code that, first they would kind of build them in hard-coded, human heuristic code ways, and they would be brittle and they would break in 100 ways. And so then they would convert that into a neural net that could handle all the edge cases a lot better, but they would still have that block that was left. And so they have this patchwork of blocks that they've been slowly converting from hard code to software 2.0, the neural nets. What they are getting to the point now is, instead of having this patchwork of blocks that essentially, and it was built just for the task of driving, it's a patchwork of blocks that gives the planner all the data that it needs to make decisions. Well, all of the data that the planner needs to make decisions really is, if you can create a model of the three-dimensional space, not only the static objects in it, but the dynamic objects that are moving, if you can get a high quality, highly compressed representation of all of the visual space around the vehicle, that anything that the planner needs can be in that. And so they're migrating this to, instead of having a patchwork of individually built blocks, to having one giant neural net that encompasses the functionality of all of those blocks, plus new things for the optimist. They want to build this one block, this vision foundation model that holds all that data in a general way, so that it doesn't just work for driving, but it also works for the bot, and they say other friendly robots. Well, one of the other friendly robots is going to be all the manufacturing bots in the Tesla factory. So all those one-armed welding robots, spot welding, moving pieces, all of that stuff, those things are also going to get FSD robot brains, and they will be equipped with cameras, and they will be able to interact based on this exact same vision foundation model. And that's just going to be the first three. You've got the car, you've got Optimus, and you've got those factory robots. Then it will be generalized into a whole number of other things. And the cool thing about this is they're going to find use cases as they build out Optimus that end up actually being things that they need for full self-driving, but they didn't know that they needed. So it's going to solve edge cases proactively that, if they were just building this general model for full self-driving only, they would continue to run into things. They're like, oh, we didn't really think about this. Well, now we've got to kind of expand the scope and how this works so that it can solve this. But if they're going now for basically a large general vision model that can do any real world interaction, then it will implicitly have what it needs to only solve the narrow thing. And so that's what, then he talks about, you have this basic general model, and then you just build little tiny pieces that you attach to the end of your vision foundation model that allows it to accomplish a specific task that you want. And those individual tasks will be things that are much easier to develop, much easier to train, and you can add them. So you're getting that foundation that then will allow you to do all kinds of cool, interesting, fun, valuable things.
Did he not talk about, as one example, was parking assist? Was that the one where
that was? Yes, that was one of the tasks that they built on top, and that was the place that they realized, hey, wait a second, because the parking is somewhat a little bit of a different task than driving, and so it needed different pieces of data, and so they're trying to build this function on top of the camera data that they already had. And as they were doing it, they were realizing, if you have the ability to pull up Phil Dwan's talk, it was kind of, I think, 2/3 of the way through, where he's got the whole.
So our next keynote speaker.
Yeah, you know where it is.
Yeah, try going about 2/3 of the way. It's where he's got the blue outline around the middle section of the flow diagram of how the code works, and then the red on the right side. It's right exactly. Yes, right here. So this is what I was talking about.
Nobody's going to understand this.
Well, so you've got if if you zoom into the right side, there's the
I can
distance
zoom in,
field.
yeah.
Okay.
Yeah.
That is that task that they're building. So
Yeah, that the parking assist there.
Yeah.
So yeah, so yeah, let me kind of understand what we're saying there. So okay, so now you've got the system that can identify, that can recreate the world, and it can predict the future. And then it did that by looking initially with all the cars that are driving by. It takes all the videos, not only my car, but every car that's ever driven a certain area. So now you could take that knowledge and apply it to very specific use cases. In the case of parking assist, they can show it videos of various ways that cars are parked and where the opening is. And it's got a map of that specific location and the curb and the distance to that. And so now the car will just know exactly what to do to get in, and it already knows the distance of that. And that's, I think, where, if my car is driving into my garage, it's gotten that video a million times now. And so now it knows where the wall is, and it knows how far away I am at any moment, and it just can predict at that point, if there's anything there or not. But yeah,
Yeah, they're
is there
trying to
something else
build
on
it
that?
in such a way that they don't actually need the map, that they have when they built the distance field, it was to replace the ultrasonic sensor. So now all of the cars can do parking assist without actually having those ultrasonic sensors, which were not necessarily great there were edge cases that the ultrasonics were not good at. And so it's like based on the height of the curb that you were trying to back towards, would it or would it not see it? And so now they're able to recreate, just like they did with LiDAR and cameras. Now they're able to recreate the input that an ultrasonic would give them, plus actually improve on it just with cameras. And the mapping is something that they can do. They do a lot of mapping right now to improve the training data, but I don't get the sense that, and maybe they'll do this in the future if they decide that it wins them points, but currently what is being rolled out to the cars and run on the inference computer, the hardware 3 or hardware 4 system, as someone is using full self-driving, they're not pulling in that mapping data that they showed that's being reconstructed from those neural radiance fields. It's just trying to use only what it sees to make decisions about what it should do, and whether that's traveling at a high rate of speed on a highway or slowly backing into a very tight parking space. It wants to be able to do all of those things accurately without running into anything, just based on what it sees there and no outside input about maps.
Okay, well, boy. So, obviously we're all watching the development of full self-driving. Many of us are still very skeptical that it's going to take. Many of us are saying, yes, it's going to happen, uh, but it's going to happen in 5 years or 2 years from now. There's too many edge cases. I think what we've shown today, though, is that there's cause for optimism that this is potentially going to be a solved problem. I know when you listen to Elon say things, many of us just discount what he's saying now. But when you hear these actual developers showing you actual new technologies that they've built, and then seeing their confidence that this is going to be enough to take us through the next, the next level to actually get this moving faster. Then you hear about Dojo, which is, you saw that it's going to be like 100 exaflops. So even if people say it won't happen this year, it's hard for people to say it won't happen in 3 years, because with 100 exaflops, if that happens, again, that's, some people will say, yeah, that might be another couple of years, fine. But it seems like all the ingredients are in place. But this was missing, this general model, this ability to recreate the world exactly to what it is, and then having the computing power to do it, and then actually test. They've already tested this. They already know that it's working. And that's why I think you can hear the confidence. That's what I'm hearing.
Yeah.
I got very, very excited when I watched these two videos from Phil Dwan, is another AI developer for Tesla. We didn't show his video, but these two from Ashok and Phil just gave me tremendous confidence that they've got what we need.
Yeah. I think the likelihood that they have, well in the tens of exaflops of compute by the end of next year is very high. And that's why I'm a little bit, I don't know how much of that compute, and this is because I'm an outsider. Like, Ashok knows a lot more than I know about how much compute is needed to initially roll that out to customers. And he is saying that they're hopeful that it's by the end of this year. My guess is that that's Elon's optimistic internal time target that, hey, Ashok, I want you to ship this by the end of the year. And so Ashok's saying, yes, maybe we'll ship it by the end of the year. Who knows? But I think that they're going to need a significant portion. I don't know that they, like, 100 exaflops is an incredible amount of compute. I don't think that they need 100 exaflops to ship the first thing to customers. I think they need a fraction of that. And so that's why, like, if they have 20 exaflops by March, the end of Q1 2024, I think that you're right on the edge at that point in time of being able to ship a very exceptional product to customers that showcases the capability of the system and really makes it clear, like, this is the solution and the architecture that is going to scale all the way to a level 4 system. It'll be level 4 functional. It will not be level 4 approved. And so, yeah, I like, my level of confidence that we have that by the end of next year is very, like, I think that by the end of the next year is a very conservative call. I think that the prediction that we have it by the end of this year is highly, like, it's possible, but that is a very optimistic prediction. And but I would say that the end of next year is conservative, especially given how fast AI is moving right now. Like, people just do not understand the speed with which all of these things are happening. And like we said, everything that they're talking about doing, this is not new stuff. They're just talking about applying things that we know work to this problem that just has a larger amount of data associated with it.
Yeah. Okay. So I agree with everything you're saying. I'm not ready to say that FSE will be solved by the end of this year, despite Elon saying level 4, level 5 by the end of this year. I agree. But you watch this and you see that they have what they need to solve the problem. This isn't like the way you described it earlier was great, which is, heuristic coded, and then it breaks, and then it kind of like, solve this problem, and then they do, and then they solve this problem. This one is a general model where you drive, every car that's driving is putting input, and then the system is able to recreate it, and then the system is able to make different predictions of the different futures, and then be able to automate. And then they did show that it wasn't just the driving; it's the identification of street signs. It's the lanes. That was the hardest part, right? He even mentioned that the lane was excruciatingly difficult, or frustratingly, whatever word he used. But once you've got the lanes mapped, because of this general model of reconstruction, it will do very, very well in a city that is static and doesn't change so much. It's got rules. This is the whole holy grail. When you see 20 Teslas driving in a certain path through this turning left this way, you're going to do the same thing, and you're going to, watch out for any differences, but your chances of doing it the right way is just skyrocketed because you've got the data. I've been saying,
agree.
I've been saying that up to now, this is the difference. Up to today, when we are using FSD beta, Tesla has been optimizing for visual labeling and visual recognition. So they treat every time I drive my car, even up my driveway or in the same streets that I've been driving for the last year, it doesn't know it. And it purposely doesn't want to know it. It wants to just react to what it sees and then going, okay, that's a stop sign, I better stop. Now, with this information, they might be able to now they are mapping a certain city, a certain neighborhood, and then it'll know already before we even get there. So
I think there will have to be, because even as a human, when you drive in a new place, you drive much differently than someone who lives there and they know the area. And I think ultimately the system needs to drive everywhere like a native in order for people to trust it, for it to have that 10 to 100 times greater safety than a human. Well, not just 10 to 100 times safer than a human that's new to the area. They want 10 to 100 times safer than a native driver in that space. And so there will be some of that ends up having to be part of the system eventually. We'll see kind of when that gets brought into the system. I think the thing that surprises Elon about how long it's taken is that if you think back to how DeepMind created their Go system, that at first they did build it, with basically in blocks. It was a neural net, but they built it in blocks, and there was some kind of accompanying handwritten code to kind of guide the neural nets. And they were actually able to get that system to beat Lee,
Yep.
whatever his name was, the best
Yep.
Go player in the world, Lee Sedol, I think. And
Yeah, Lee Sedol.
so I think Elon was expecting for the FSD software to actually work at that level that's better than a human, still having that patchwork of blocks, and that eventually it would get better. Now we know that DeepMind, after that, they built different, AlphaGo, that learned the rules. They didn't give it the rules. They just said, play each other, figured out what the rules were, and figured out how to actually beat the expert system. The first one that beat Lee Sedol with that. Well, Elon's finding that is the level that you're driving is such a hard task that you're having to go all the way to that level to begin with in order to finally get a system that's better than a human at driving, just because driving is so much more complicated. And what really, it's more than driving is so complicated. The real thing is you're operating in the real world, which is unconstrained. And so the degrees of freedom of the real world is so high that even though your control outputs are just brake, acceleration, and steering, you're still having to account for hundreds and thousands of degrees of freedom of all the other things that are moving in the space. And so it is requiring that end-to-end approach in order to actually get the first system that works at level 4.
I love that you brought this up, because I think this is probably accurate, good comparison, right? So my understanding was AlphaGo or DeepMind's Go, when they, in order to beat the game of Go, they initially said, watch all these videos of humans playing Go, and then you play against the human. And the human, the way that they played Go, that was teaching the computer how to play the game. And it worked, that was fine. But then what they decided to scrap that model, and they just went 100% simulation, and they just let the computer playing against themselves. And they didn't, like you said, they didn't teach them any rules. They just said, here's the goal. And then after millions and millions of iterations of it just running on its own, it did it within days. And it was now the best player ever. It was making moves that no human ever made before. And they're scratching their head of why would it do that? But it was kind of, it taught itself in the same way. Now that we're able to do general model of reconstructed 3D space, they can now do this. They can basically have the computer play itself and play all sorts of futures. They can tell it to do one thing and then do that a million times until they figure out how to do it right. Those kind of things can be happening so much faster than just us driving FSD beta and trying to say, yeah, it's a disengagement here and disengagement there. That's not as important anymore. And then let's bring it back to bots. The key part of that was that I don't know if I actually played that part. There was a key part where he said the hardware, the software, the neural net, everything that we just talked about applies to bots as well. That's a big deal. That is a big deal.
And we talked about it a little bit already. Yeah. The fact that this visual foundation model, because they're making it in a way that works with bots. So when they were developing FSD and they started using the hardware and the software from FSD for Optimus, they found there's not that many things that I can pull into the bot and have it be useful. Like the occupancy network was really the only thing that they talked about that was shared from a software standpoint. It was running on the same hardware. We've heard, I think it's likely that the Optimus chip only uses one socket versus the fully redundant one that they have for autopilot, and that's probably just a power draw requirement. But so it was running on the same hardware, and then they only had just the occupancy network. And so that was where I think that was also one of those key aha moments for the Tesla team. Like, we need to make a more generalized bottom layer foundation that works in both the car and Optimus, and that then you can feed it into different types of decision-making planning algorithms that are going to do different things in different types of environment, but you still have that same base layer that's shared between both things. And so the occupancy network was the first piece of that. And they're like, okay, how can we make basically the occupancy network 2.0? Like if the occupancy network was everything that I ever wanted in both different scenarios between the bot and the car, what would that product be? And that was really the genesis of actually creating these vision foundation models, which to be honest, this has been the clear path that needed to happen for a long time. George Hotz was talking about training comma AI end to end, but just because you know that that's where you have to end up doesn't mean that you know that like part of the deal is you need compute that Moore's law just hasn't caught up yet. Like we can't do that yet until we have the compute to do it. And so you have to get there, and you're learning along the way so that when you have the compute resources, you know exactly how to maximize them, and you can pull forward, like you can get the most performance possible out of the least amount of compute necessary to do the task. And then 5 years from then, it'll be trivial because you'll have tons more compute. You'll have the software figured out. It'll be much better. I mean, this was the exact same thing going back to the DeepMind and AlphaZero. Demis Hassabis was asked, why didn't you just build the end-to-end system to begin with? He's like, we couldn't. We wouldn't have known how to build the end-to-end system properly without going through the exercise of building the first patchwork block type code system. And then once we had done that, it gave us a full understanding of the system to where we could create that end-to-end architecture to begin with.
Wonderful. Thank you so much, Hans. I appreciate it. Follow Hans on his YouTube channel, Hans C. Nelson. Appreciate this. This is a breaking news that we had at the beginning, 52 job openings for Tesla bot. And then we walked through in detail. I will put links for Dr. John Gibbs DrKnowItall. He explains those two videos that we just walked through in detail, but they're worth watching if you're a Tesla investor to really understand if you think that the Tesla is on the right path. I'm bullish. Thanks, everybody. Thank you, Hans.
Thanks.